Hi, everyone. And today, welcome to our podcast. We are having this podcast after a while, but I'm really excited to welcome Jyoti, who is also my senior from
Thank
IT
you.
Kharagpur. And
Thank you,
he
Tanis.
has lot of, hi, Jyoti. He has lot of geophysical experiences and who believes in the data. His travel will know more about his travel, and he's also transitioning in from a geophysicist to a more as an energy domain expert. So let's hear it from Jyoti. Hi Jyoti, welcome. And
Yeah,
if you can walk us through your experiences as a geoscientist and then your experiences with dealing with data and now the transition you have done into more broader energy domain, will be more interested to know about it.
yeah. So, hi Tani and hi Vishal. To give a brief about myself, I passed out from IIT Kharagpur from Geological Sciences, Masters in Geological Sciences in 2006. And since 2006, I have been working with uh, oil and gas operators, oil and gas service providers, and uh, uh, trying to learn things along the way and uh, making myself more aware of the data that we have or the surroundings we have, the and how can we make most out of those data and surroundings or surroundings. By surroundings, I mean the people who are already working there and peers like Vishal and you. How can we learn from each other? So
Mm-hmm.
uh, I have been doing that for a kind of more than 15 years now, and since the so currently, I'm working or I'm leading the team of New Horizon Geoscience for projects, mostly for oil and gas asset management projects. We advise uh, asset owners. Asset I mean it's a oil or gas producing or revenue making field, maybe green field or a brown field. So we are expert in evaluating the asset, making the reserves estimation, uh, trying to find out the positives, negatives about that reservoir, and uh, make it available in the market as a as a valuable asset or putting that asset in the market. So we help the mostly we work as asset in the asset management area. We work with those operators who want to sell their asset or who want to kind of farm out their asset or who are seeking for larger investment. So this has been the and we do that with the all the technical and financial uh,
Mm-hmm.
angles that is involved or techno financial aspect that is involved in the asset management process. So that has been the prime target for some time now. Um, uh, and At present, from being a from a geoscientist point of view, at present I'm kind of uh, the learning has never stopped for me, and
Mm-hmm.
maybe it is starting from the basic steps of how to interpret data or how to make meaningful inferences out of the data we have. From that to taking major decisions about a producing asset. The learning has never stopped. The most important part of the learning, I would say, is the data science part, where we are preparing reservoir models, we are preparing simulation models, and we are continuously dealing with data and playing with the data through um, geostatistics, through uh, solving equations, or
Mm-hmm.
maybe it is the raw data about reservoir or about um, a geological data or any kind of well data, and
Yeah.
how to uh, I would say not. Uh, being agnostic about the softwares or tools that we use, but to be able to realize that what this data mean in a
Yeah.
kind of yeah, in a way that that makes most sense. So
Yeah. Mm-hmm.
that is the so that part has been major. So through this process, I had to learn geoscience. I had to learn data science. I had to learn a lot of tools through which data can be processed or pre-processed, post-processed, visualized, and everything, and then uh, make meaningful or make try to answer the questions that the operator or the owner of the assets are most worried about, that how much my reservoir, what is my reserve, how much reserve I have, how
Mm-hmm.
much through how much time I can produce in a particular rate, or what can I do
Right.
to enhance the production, or if I want to ramp up my production, what steps should I take? So those answering those questions through the data or through the
Mm-hmm.
interpretations we make out of those data. So this has been the job so far.
So, you mentioned about data modeling. What kind of models are you using? Is it like machine learning models or some other stochastic models, or what models are those basically?
Yeah. So when I started in 2006, at that time, model used to mean 2D model, static model, 2D models. It was
Right.
not even 3D models. It was 2D models where we used to calculate everything on a 2D map, and then
Mm-hmm.
either you multiply or divide, or you put some equations and get the result. The result is also in terms of a 2D map. So that was the
Right.
first 1 or 2 years that I saw that this has been a regular practice. And the regulators at that point of time in India and outside India, they were not much worried about the 3D model or the simulation model. They were worried about the and that was the time when uses of computer has become mainstream for processing, for data processing, for visualization, and for mapping. So
Mm-hmm.
that was the era where I entered the industry in an era where everyone had a desktop, maybe 2 or 3 monitors,
Mm-hmm.
and with a powerful Sun microsystem machine, or maybe mostly Sun machines, and maybe some HP and Dell machines also, but mostly Sun machines and big screens. At that time, I can remember that we used to have maybe if you have 64 GB RAM in your system, then you are like really having a powerful machine. So 64 GB RAM means you are doing some high-end computing, so that you need that much. Now we get 64 GB RAM in any kind of machine. So 64 GB RAM is a very like common minimum configuration now for all the application.
Right.
But at the
Yeah.
time, for the first time I saw the 64 GB RAM machine in 2008, and it was strictly for visualization and do the 3D slicing through one of the tools to see seismic attributes through 3D slicing in a particular time band. And we used
Mm-hmm.
to extract data of that attribute in a particular time band, and then see the time slices. So for to visualize that, we needed a very high graphics and high end machine. So that was the time.
Mm-hmm.
So from that 2D model, 2D model was very mainstream at that time when I started. And then the 3D modeling was catching up. Those were stochastic models and also deterministic models. So geostatistics was kind of picking up as a subject in USA and Europe, and people are coming with a lot of new algorithms to how to use kriging and co-kriging and ordinary
Yeah.
kriging
Right.
for population of data, and uh, also come up with new ways of looking data, like uh, from the uh, normal geostatistical realm to Bayesian realm, I would
Mm-hmm.
say. So Bayesian came with the involvement of geophysical data. Bayesian became more and more stronger, like taking a priori this either you start with an assumption and end with a result, or start with your data and assume that your mean is something, or your unknown is something, and then arrive at result. So those kind of things we were experiencing for the first time. So how it will look in a Bayesian path, or normal geostatistical path. So those are the time, those paper Abrahamson's one of the famous paper on this uh, geostatistical inversion, or initial inversion, data inversion,
Mm-hmm.
was Abrahamson's paper. Abramson is a scientist who is working in Norwegian Mathematical Institute, I would say. I don't know the full technical name of that thing, but those were the time when these papers started coming, and 2008, 2009, 2010 was very landmark time in modeling, because Petrel started in 2008, and Petrel is kind of the one of the most
Right.
dominantly used platform in
Yeah.
normal commercial geoscience space or oil and gas space. And Petrel started in 2008. They kind of we saw Petrel in 2009, 2010, and Petrel started to take off from that point. And so once Petrel started to take off, and other tools which were like GoCAD, SCOA, and other parallel technologies who were kind of pioneering the 3D modeling space. And so they started to become mainstream. And also parallelly, the geophysical applications, like the technologies like Hampshire Russell and Jason, they
Mm-hmm.
came up with attributes, 3D attributes, that were only you will only be able to get the most out of your data through a
Yeah.
3D application like JSON and paradigms visualization softwares like voxel geo and all that. So those are very powerful tools at that time. And
Mm-hmm.
we kind of for me 3D become very mainstream around 2010. And people and at that time also 3D model became one of the necessity for development through the regulators made it that you can use 3D models for calculating reserves and reporting reserves and all that stuff. So it was not mandatory then. By 2012 or 13, it became mandatory, but that is the time when it started and started to take off. So at that time, data learning was became very essential for all of us who were in this space, who were using all these tools and all these algorithms, all this
Mm-hmm.
new way to look at the data. And a lot of our colleagues, they were experimenting with attributes, variance or
Mm-hmm.
double variance, or variance with combined with some other seismic attribute, or uh, some function of variance. So those became kind of seismic attributes became very back-end experiments in all the geoscience teams for all the operators and service providers. So they were like uh, that was the time when most of the attributes came, the ad tracking and whatever we see
Mm-hmm.
at this moment. I would say those were the initial experimental time of not AI, but uh, not pure AI. We cannot say it's a pure
Yeah.
AI kind of thing, but
Machine
it's
learning.
just
Yeah.
some,
The
yeah,
supervised,
machine
some
learning,
supervised learning. Yeah.
supervised.
Right.
Yeah,
Mm-hmm.
so we can
Mm-hmm.
say. So I remember that we used to use this uh,
Yeah. Neural
uh,
network. Yeah.
neural network, supervised and unsupervised. It was not very perfect, but yeah, we can make use of that. We could make use of that. So that was the starting point of machine learning, and initial part of predictive
Yeah.
kind
Right.
of geoscience.
Right.
So that data was becoming more and more prominent. And so after that, I would say 3D 3D visualization, 3D applications, and 3D modeling and simulation, that became very mainstream. But still, the simulation, because for the ultimately all the data that all the interpretation that we generate, that goes into a simulator, and where the simulator predicts, it kind of uh, validates the model, and based on the validation results, if it's a very good validation, that is done through a process called history matching. If the history matching is good, then the model is validated, and then the model is used for kind of predicting the performance or predicting the future production from that particular reservoir or that particular field. So that is a very powerful decision making tool, that decision makers, they need numbers, that what is my 5 years revenue looking like,
Mm.
or 5 years next 5 year production is looking like, or what steps should I take today to ensure that my reservoir will produce at a very optimum rate. So those kind of decisions were being able to we were able to get the answers for that purely from data perspective, not from any this person has a lot of experience, and not from a very non-objective way, but from a very objective point of view, we could say that this should be your answer because this is backed by this data results and interpretations
Right.
and all these numbers. So that is when the operators could realize the uh, potential of data, and how this geoscience and geophysicists, geologists, petrophysicists, reservoir engineers, how they are very important for overall success of for the uh, production or maintenance of oil and gas reservoir. So
Right.
that is the point, that is the era when they were able to understand from a data perspective that we need people to understand this data and to do more things with the data so that we can
Mm-hmm.
answer these
Mm-hmm.
questions very meaningfully.
Yeah.
So, and
With far
also
more confidence. Yeah. Yeah.
yeah,
Yeah. Right.
and also one aspect is, if we see the timeline of the regulations when they came, like in US they came up with the when in US you have a particular way, or US Energy Department, they have a particular way to report your reserves, because these reserves and numbers are very sensitive. Like oil and gas companies, if they give a false number from which is not there, actually their shares can be they can manipulate the shares. So uh, to stop that, US came with the regulations to how to report numbers, reserves,
Mm-hmm.
how much oil and gas are there in your reservoir. So there is a particular way how you report. So that also made a lot of impact throughout this process, and a lot of processes were streamlined in geology and geophysics in this with the date when so one is the data and one is the regulation, so they has to go hand in hand. So a lot of we can say the data formats, last file. So last was last format. So a lot of formats were created to support this
Right.
last
Mm-hmm.
format, we can say. And that was the time when a lot of people who are actually good in geoscience and also good in computer, they started writing codes and started sharing them freely with as a community basis,
Yeah.
and
Open source
forms
kind of.
open
Yeah.
source. Yeah, so the open source
Right.
movement also started after
Mm-hmm.
2010,
Yeah. Right.
since 2008 2010, that time. So a lot of things went into that period, and 3D became very successful tool, very profitable for the operators, very engaging for geologists, geophysicists, reservoir engineers, petrophysicists, data, and I would say very confidently that all the geoscientists, geologists, geophysicists who are like doing data processing, or
Yeah.
doing inversion, or doing high level algorithms, so they were already in the data science part before the data science revolution really took off, like
Yeah.
after the 2000, like we the oil peak was 2012. So we reached $120 per barrel, and before it got crashed by the ISIS movement and all that. So that was kind of 2008 was the lowest because we had the Lehman Brothers collapse and oil price also went down. But it was for a very temporary period. And from 2008 to 2012 was very good period in terms of data, in terms of
Mm-hmm.
sponsorship for all this application development, 3D visualization, data,
Right.
mostly for the data part. And then after there was a slowdown, we all know that we went to like negative numbers, or in 2015 the oil price was like hovering around 30,
Yeah,
even
it was
below
really,
30, it came
yeah,
below
bad.
30.
Yeah.
Yeah, it was bad. And then so uh, one thing happened after 2015 is the data revolution, the cloud computing started. So
Mm-hmm.
I have been experienced that because I was leading a team at that time for a application provider or service provider like Petrol. It is competitor of Petrol, and they also provide the same tools as Petrol. It is called Rockstar, which is owned by a company called Emerson. So we were planning to put everything on cloud in 2016 or 17. It has already started. So cloud computing was already there, and people were strategizing how
I think there is a internet issue on
all are aware of like
Jyoti's
Microsoft
end.
360. Yeah, so
Mm-hmm.
that movement started in 2015, 16, and it continued till 2020, till we got COVID. And
Yeah.
post 2020, it was, I think, a lot of experiment had already happened with AI domain. Before that, the random forest and the algorithms were already there, but how to use them for like geostatistical or like geospatial data, I would say. We in
Yeah.
geology and geophysics, we have geospatial data. It's not a time series data. So
Right.
the for AI to make better prediction, they make better prediction with time series data. But for us, it's a geospatial data. It's across like space and across geography. It's not a time series data. And so how to modify those algorithms to suit our need. So a lot of work happened in that era, and automatic fault picking and automated horizon picking,
Right.
or so a lot of automations started happening, like automatic fault log interpretation from resistivity log, or gamma ray log, or neutron porosity log. So lot of automation, I would say, algorithm based automation, and also some AI came into those kind of algorithms. So that is the period when it started for geoscience, also the AI part.
Mm-hmm.
At present, I don't know, I cannot say that AI based models or physics based models. So a lot of comparison happened even on LinkedIn, and a lot of experts who are suppose me, I have been using physics based models for prediction, and suddenly AI based model is kind of there as an alternate. So we are bound to face this question, that which model now is better, AI based model or a physics based model. So also a lot of operators, they were interested that if AI based models can really help us, because that is the future, and that is where all our sensors and data, scanner data, those are going to be. So all the data that is coming from the field, if they are like the digital oil field concept started, and so the operators were thinking that for our digital oil fields, whether the AI based model is good or physics based model is good.
Yeah.
So from my take on that is physics based model uh, are kind of they have a they have a mature level of uh, technological maturity, or I would say there is a certain maturity with the physics based model, where we can clearly say that how much of our prediction is accurate, or the probability of our prediction. uh, but in AI based model, uh, in AI based model, we have not yet able to control that prediction ability.
Mm-hmm.
AI based model also they also represent uh, they also represent certain processes that are very robust, and that can really help in prediction. But I cannot say with a lot of confidence that currently we have tools or algorithms where we can easily control the prediction, or we can validate the prediction of a AI based model. And sometimes what is happening is AI based model are created, and physics based models are created to validate the AI based model. So again, the purpose is kind of
Yeah.
yeah.
Negated.
So
Yeah.
yeah.
Right.
Today we are having both AI based model, working with both kind of models, AI based models and physics based models. From my asset management point of view, I would say that uh, AI based models are already there for asset management. Suppose how AI based model are making a good contribution here from asset management point of view. Suppose you want to know that I'm working in a certain type of reservoir, let's say tight sand reservoir, and I want to know that uh, what is the global method if I have a centralized database of, let's say, 200 reservoirs, and I have all the data from that reservoir, and I have backend, I have automated all the calculation, log, geophysics, geological calculation. I have like fair amount of automation, and
Mm-hmm.
uh, I can answer the questions. Let's say my system or AI based system, it can answer the questions which I'm going to ask, or it can give me numbers. Then uh, those platforms are already there. So they are now going AI, they are now at a very suitable place to go to the AI space or merge with the AI space, because now if my question is that tight sand reservoir, what parameters should I take, or what are the ideal parameters that operators or my database is showing, or from the papers, or from the research papers, from the uh, articles, or from the normal discussion. If I have some parameters, normally we search for what should be the cutoff,
Hmm.
what kind of cutoff should I use. So those kind of questions can be generative questions, can be uh, or genetic questions, I would say. Those questions can be answered by genetic AI. So that is where I see a lot of contribution from AI. And
Yeah. Yeah.
in fact, people are using that. Lot of companies like Bloomberg Energy, S&P Global Energy. S&P Global is now the owner of IHS. So IHS used to use that. So now S&P is also having that. Then so companies like that, they have such platforms where they have the database of a lot of types of reservoir, and they can do this genetic search, and uh, kind of get a response as a genetic AI, or uh,
Yeah.
through either through AI based models or physics based models, or a combination of those models. So that is
Yeah.
where, from geoscience point of view, we are, from my perspective, what I'm seeing on day-to-day basis, and with working with operators and all that. So yeah, that is the entire
No, that is
modeling
a very good
experience here.
explanation. Like you,
Yeah.
continued from, yeah. So we can definitely understand that there is definitely the scope of AI improvement. But you can never rely on an AI model 900%, even not even
Yeah.
90%. Like you always
Mhm.
have to have the human in the loop, right? I mean, you
Yeah.
can definitely the AI models can bring down your like you can, because you can work with a lot of data. AI models can be trained on a big data, or even if it's
Mhm.
in a different region, right? Then you just have to make some tweaks in the model, train the model over there, right? I mean, those are easier. The pipe Once the pipelines are defined, it's good that AI models can get trained in any region. But anyway, I would say like every time you have to compare with either like a like a human in the loop, or in like a small physics based model, like some stochastical parameters. Otherwise you have to control it, of course. But
Yeah.
as the technology is developing, and more explainability is coming into AI, I think this is possible. Like the merging of the physics and the AI based model is what, like an ensemble of both of these has to happen every time, I would say. Yeah.
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 So
No, it's a very good explanation, Jyoti. And do you want to add anything more on this? Like, that was my take. So,
yeah, so one of the question was, any interesting paper that was presented in any conference. So
yeah.
this is a poster presentation that we did at Geo India in 2018, in 2018 September. So it was Geo India conference. So there, uh, we tried to develop an automated algorithm where, uh, to to predict the uh, tops depth of the tops that you are going to for any exploration well. So from the seismic, we have the seismic data, 3D data, and then we have our interpretations. We and because the check sorts were not available for the entire field, and maybe the well data is also not available for the entire field, and for some strategic locations for that particular field, and your velocity model is not very robust because data is not there. You have only check sorts at only 2 or 3 wells, and maybe it's a 300 square kilometer field, and you need at least 30 wells to control that
Mm-hmm.
area, and you have data for only in 3 wells, and you have some geological references with during the drilling or markers, so you can mark it, seismic markers, which you can correlate with the geological
Yeah, I did it.
cuttings
Sure.
and
Yeah.
drilling
Yeah.
samples, and those you can mark. And so a model was created with uncertainty wherever uncertainty in the interpretation, uncertainty in the fault uh, placement, like horizontal and vertical both, because we don't know if the fault is extending beyond that, we don't have well control, and also where is the fault exactly on the horizontal space. So a lot of what we use a lot of uncertainties to, and we built a model where this uncertain we built a model with these uncertainties, and then created a structural model, uh, and the velocity model is kind of a part of the structural model now. So the velocity model will be used to calculate or the depth markers. So this velocity model is now sitting with the structural model. So the structural model, one of the attribute of the structural model is the velocity points.
Mm-hmm.
So it's a 3D model, and from there we could say that wherever you want to drill, it will give you at the tops possible depth of those tops with
Mm-hmm.
certain probability. Like this having this suppose uh, to the myosin top, the myosin tops, we are predicting that you will, if you drill at this location, you will hit the myosin top at let's say 1600 meters, and the probability is 80%. So it
Hmm.
will give you a probability along with that marker.
Yeah.
And then for all the tops you will get a probability, and you will also for any all the intersections, well, and horizon intersections, you will get a PDF. So you will get to know that which depth has the highest probability.
Yeah.
So
Yeah.
so we presented that it was a lot of uncertainty built into one model. It was highly automated. So and because we nobody in India, it's very difficult to get data and work on that data and publish it on a conference. So we did that with one US teapot dome. So that's a free data from US. So we used that data and proven gave the concept to the audience. So after that, ONGC agreed to do one project with their real data. So we did
Hmm.
apply that method later on with ONGC, which is National
Yeah.
Oil Company of India. So so we have so that was one of the most interesting paper that me and one of my colleague we worked, and it was a combination of it was really a combination of geology, geophysics, and data science, because uh, a lot of people, what when we presented the paper, a lot of people thought data science is simply uh, y equal to mx plus c.
Hmm. Hmm.
So it can be as simple as that. There is no uh, there is no denying that, okay, you a function, a regression equation can also be a very uh, sound or bold uh,
Hmm.
data science aspect. But to understand, come to a point where we are telling you that, okay, if you the probability of getting Bayesian top at certain xy location, and we are giving you the probability. So
Hmm.
so we try to communicate it in the languages of data science, that whenever any stochastic model is presented, so all the answers, they come with a probability.
Right.
So
Right. Of
that
course.
was
Yeah.
the, yeah. So I would say here I would say in a cell the porosity is 20%, but the porosity is 20% with a PDF. There is a
Yeah.
curve
Yeah.
which is saying that 20% is the highest probable,
Right.
having 20% porosity is the highest probability of having 20% porosity. And if you will see the PDF, you'll also get a 10, also get a 25.
Yeah. Because of the confidence
Yeah.
interval. Yeah. Right. Yeah.
So everything is possible here, but the probability of getting a 20% porosity in this cell is the highest. So
Hmm.
we had to really communicate that part, and people were very appreciative of it. And that was one of the very kind of engaging uh, paper or poster of that conference. So that is one uh, that is the one I can remember. There are a lot of other papers also on a lot of other mostly on modeling part. Uh, but yeah, so
No, no, this is very
I
nice that you
yeah,
shared this.
I can
Yeah, I
discuss
and
more about those papers. Yeah.
if you can also share the link to that conference, I will post it on when I'm posting this podcast, so people can also have a look.
Sure.
Yeah,
I'll try
yeah,
to find out that poster.
yeah. Okay, yeah, definitely. So, thanks, Jyoti, for sharing so much valuable information. And I think we have to do a, a follow-up podcast talking about your
Okay.
more on the data science perspective, how things are working. maybe giving a little bit demo to the
Sure.
audience. That will be a very nice way. When we have done quite a bit of AI work, we will
Mhm.
be also, we can also pitch in like our colleagues and all. So
Yeah.
thanks so much, and maybe we'll just do a follow up on this also, uh, with some exercises for the
Yeah,
audience.
sure, sure.
Yeah,
So,
that's
just
okay.
before you conclude, from the big data and AI perspective, so see, you cannot deny that the usefulness of big data. Big data is very
Yeah,
useful. Yeah, so that is already been established, and people are trying to create data lakes, data whatsoever,
yeah, warehouses
uh,
and all. Yeah, yeah,
data warehouses, and spending a lot of money, or building the architecture of what should be the data type, or whether we should go with GeoJSON or we should go with uh, something like SQL, or what should be the framework and all that. So people are really discussing that, and these are useful because big data is already contributing in a positive way. And I think all the companies that are working on the big data right now, they need to, suppose your company is working on big data and AI, so they also need to think about this aspect that currently energy industry or oil and gas industry is not one of the is not the only stakeholder in the energy sector. So there are other fuels or synthetic fuels, I would say, or because people are trying to create biomethanol or biomethane or bioethane from green hydrogen, or
yeah.
through some other processes from, let's say, from completely other sources other than drilling into subsurface. So uh, we need to have an architecture which can accommodate, and a lot of this knowledge that we have in the oil industry, they can be very useful
Other,
uh,
yeah,
to the overall energy sector, because
yeah.
uh, the overall energy sector is still because I have been working on both the projects. So uh, the other parts of the energy sector, other than oil and gas, they have not yet they're yet to reap the benefits of statistical means or normal. Uh,
Mm-hmm.
so they are mostly they are using mostly optimization techniques, and they're mostly using time series data to optimize things. So that is the highest level of uh, algorithmic or I have seen so far. So they're trying to solve the equations, energy equations, which are optimization equations through through linear programming. So they're trying to optimize the either it is a cost optimization or any other factor, and try to optimize that through linear programming. So that is one of the aspects. But these skills that we are discussing about in oil industry that we have been using, they are yet to be
Yeah,
used in
yeah.
that aspect.
In the
So
other domains, right?
in the
Mm-hmm.
other energy sector domains. So from the big data and AI point of view, if you are making something where you are also thinking of making that technology uh, versatile enough to accommodate those parts, or how can we, so I don't know how to do that, but ultimately we have to kind of do that, because
Move there.
uh,
Yeah,
yeah,
for sure.
because
Mm-hmm.
in geophysical technique also we are trying to accommodate geothermal drilling now,
Yeah,
like how to find out hotspot for geothermal drilling. So uh, so if certain algorithm is not capable of identifying those, that will not be useful for the geothermal energy part. So that is what I'm talking about, that to create something that can be used for all the aspects of energy, to whatever extent we can use those
those.
interpretations or those
Yeah,
algorithms. So that is one thing that uh, I would like to see, or or maybe it will come
Yeah, it will
in
come
the near future
in
that we
near
see
future
algorithm.
for sure. Yeah, of course.
Yeah, that is the
Okay,
only thing that
that is, yeah,
yeah,
we need to have a definitely a follow up with this podcast. I mean, to talk about more on show some data to our audience because we have given theoretical, but it's good to also, so we can arrange for that. But for now, I
yeah,
think,
sure.
so thanks so much, Jyoti, for sharing your insights.
Yeah,
And yeah, yeah, I'll be posting it, and I hope our audience would definitely like this discussion that
yeah,
we
sure.
had. Thank you.
Okay, thank you.
Thank you, Vishal. Thank you, Tani.
Yeah.